Howdy, and welcome to Broken Tool Garage. This time, we're going to be answering a question that I have, and that's, what's the best insulation? So what I've done is, I've built this test rig to answer that question. So some of the insulations we're going to be going over is fiberglass, good old classic fiberglass, right? Versus some of the newer bubble insulation. And we got foam that we can test. Kind of a house wrap-ish Reflectex barrier right there. We're going to be comparing all these insulations to each other to see how they perform, right? That's how we're going to answer that question. What's the best insulation? And then look at how much they cost, dollar per square foot, right? So before we get too much deeper, I want to give a big shout out to Todd at Project Farm. He does excellent videos, and he has inspired me to actually record this, because I was going to do this anyway, but I'm recording it and I'm presenting it to you, who is my peer, for peer review for the experiment that I'm conducting. Okay, let's take a peek at some of these insulations. So I did mention this right here. This is Reflectex's radiant barrier is what they call that. It's kind of like a house wrap type stuff. It's pretty thin. It has, you can see the little dots in there, kind of like little baby perforations in it, so that any moisture, if it does get in, it can escape. So this would be something that you put underneath your metal or your roof or whatever, or you can use it on the wall. It's kind of like a house wrap right there. So the other thing, I'll talk about this, how I made the block, but this is just the spray foam. I just used a can of it because getting the actual industrial stuff is, it'll cover like 200 square foot, and it's like $380 something. So I just got the $6 can of the big gap filler and used that right there. I'm going to consider that one of my bookends of this should be better than all the insulations, right? And putting no insulation in there should be the worst that we could do, which is also the cheapest. And I have, this is also Reflectex, just a single bubble, double reflective bubble wrap right there. All these are made to do 1 square foot. That's what the test rig is set up for, right? And then it's a 2x4 thickness, which would be like your rafters or your joist or something like that, right? Or your wall studs. And we have regular old, I forgot what brand I got. It's whatever I got locally. I forgot even what store I bought it from, but just regular old fiberglass insulation right here, and it's cut to fit into the box as well. Now a couple other things I'm going to test just because I had them laying around is just regular old house wrap. I think this might be the Home Depot one. It's just your fiberglass house wrap. It's not an insulation, but it does do something, or does it? And this is kind of its cousin right here, which is the underlayment. It's just like a coated house wrap for use underneath your roof instead of just doing your walls. So that's all the insulations I'm going to be testing in this video. This is the foam block. I made a little jig right here, and this is roughly 1 square foot, so it can drop down into our box up there, right? So what I used to fill that in with is the Great Stuff Big Gap Filler, up to 3 inches. This supposedly does 5 square feet. That's not the result I got of it. I did 2 layers, let it cure for a couple hours, and did 2 more. And you see kind of at the end where we're not super poofy like over here. It looked like brains, because I was just shaking this can and trying to get every little bit of it that I could out of it. But it did fill the 2x4 gap up here. So once it gets cured on, go through and cut this out, and then it should drop down into our box for testing right there. This is rated at 3.7 R value per inch, and this is 3.5 inches right there. So now the thing is, I use this can. This is not what this is really supposed to be used for, but going to the cat over here has showed up a few months ago, and he eats mice, and he loves being petted, and right now he just feels neglected because he's not getting petted. At least he's not too vocal. Anyway, so this isn't what you'd use. The kit you would use for this, the do-it-yourself kit, would be like $383 is what I saw, and it covered 200 square foot. A little overkill when I just need 1 square foot. So, but anyways, that's what I use. I'm going to use the pricing for the kit that's supposed to be used for this, and I don't think even that kit is meant to completely fill it in like this. I think it just sprays on there and you just do 1 coating of it, and then it comes out to however thick it is. The one I saw was rated for R value 6. So if you did 2 layers of it, you could probably get R value 12. I don't know if you could fill the whole thing up or how thick it is. I don't have experience using those kits. I know what they are. I've seen them used. I'm just not experienced enough to really tell you what we got. But this isn't what we're trying to test. This is our bookend of this is the best you're going to get right here versus no insulation is the worst that you're going to get, right? And then all the other insulations we have will be in between these 2 bookends. Okay, here's the test rig. What I made was a box right here, and it's got an upper chamber in here that has nothing in it, right? And I'm going to use this tempered hardboard for our top and our bottom. If I get my bottom piece over here. The bottom piece has a little spot for my temperature probe to go in, right? And what we're really going to be measuring is this heat lamp, putting heat lamp into this board and what makes it through this board and to the bottom of this board, right? So this slides up in there. I got little screws in here to set the distance on it. And let's see here. Let's tilt this down so you can see what is in the upper side, or I can just do this. Okay, I also have a temperature probe here, and what that's doing, it's testing up inside. Basically, once the heat gets through the top panel, any heat that gets into the insulation, I'm testing it. I'm not using that for any of my basis of how things do. That's just kind of a good judgment of once the heat makes it to here, I know that it's going to make it down to this panel here, right? Because we got our other probe up in there. Get it kind of mocked up in there, right? So once this temperature here starts dropping, because what I'm going to do, I'm going to run the heat lamp for 10 minutes, and that's going to apply a bunch of heat into this box and into the insulation, and then the heat will transfer down to this bottom board. So once this temperature probe here starts dropping, then I know that I'm almost done with the test and all the heat soak is done, right? So kind of what happens is once the temperature is applied, this is going to be warm and then this is going to be cold, so the heat's still going to want to try to come down to this bottom board and heat that bottom board up. I'm also going to try to keep my test short, so that's why I do a 10-minute light on, turn the light off, and then whatever the heat soak is. So such is the case of nothing, which is going to be our first bookmark of if I did nothing, which would look like this right here, just a panel. And I got screws to screw all this down. We'll look at that here in a minute. So doing nothing took about 5 minutes to reach the maximum temperature on the bottom board. And what I'm going to be recording is what is the highest temperature I get on this bottom board for 10 minutes of this 250 watt heat lamp applying heat to there. So I also am recording the temperature of the shop and making sure that it's not changing, which through all the testing, I had no temperature increase or decrease in the shop while this testing occurred. So I'm not getting any additional environmental effects going on there, right? So the other thing that I want to show, let's get up here. I just have a it's just a dual temperature unit right there. I turn it on and we got temp probe number 1 here, number 2 right here. So you see, like in the shop, it's 55.6. What I do, I come over here and take the maximum temperature. I let everything kind of stabilize. I record temperature 1, I use that for the shop temperature and the bottom plate temperature. Then I hit temperature 2, so that's 56.1, and I record that. Again, I'm not really using this upper one for anything other than informational purposes only right there. So I'll turn this on, I'll let it run, and then once I reach my maximum temperature and it starts coming back down, that's going to be the temperature I record right there on how much heat transferred through there. Okay, so the heat lamp's on, and basically I would do nothing. The garage doors, all the garage doors are closed. There are no fans on. I'm not walking in and out during the test. And I just let it sit there and heat soak for 10 minutes, right? Or apply heat for 10 minutes. And then I'll do the heat soak, depends on the insulation. We're going to get a temperature rise, continual rise, even after the lamp's off, right? Because we heated this panel up a whole lot and it's still transferring heat. And this top layer up in here is going to be hot because it's just absorbed heat and it's trying to transfer heat all the way down and into the box. Now I do have leakage coming. As soon as I turn this off, I do start getting some leakage coming out, right? So given I've tested everything the exact same way, that's going to help mitigate that. And also keeping the test short is going to help mitigate that right there. So we're getting reliable results through everything, right? So one of the things that we got going on here, this is simulating, since this is a 1 foot inner dimension, this right here, given it's a 2x4, is simulating, this would be like your rafters or your 2x4 wall joist right there. So that's how this applies more realistically than what you get is if you're doing just a pure R value test, which would be a panel, your insulation, and a panel, heat transfer straight through, right? The other thing, like the reflective insulation, it may or may not do better if we didn't have this panel on here blocking the reflective quality of it. So we're actually testing the material quality, not the reflective quality of it, by covering it up. Because, I mean, I'm not going to have reflective insulation on the outside. That would be really annoying, right? At least to the neighbors anyway. So that wouldn't be realistic, so that's why we got our panel on there. This is just representing whatever your siding is, and it's thin enough so that we have something that blocks the direct infrared, but it's also thin enough to not add any substantial amount of heat resistance, because that's what we're really testing, is this as a resistor. Think of it like electricity, right? You put a big resistor in there. This one not so big of a resistor because there's nothing in it, but as we add insulation, that's adding resistance to the heat trying to flow back out. So we should be, again, we should be getting a similar result to what you would have in your house or shed or something like that, right, with this rig. Okay, take 2 because it recorded my webcam. So I have this chart set up for our temperature rise that we got with the 10-minute input energy of the 250 watt heat lamp. Doing nothing, the bottom plate achieved 13.9 degree temperature increase as a maximum. Then we go down to our house wraps, 11.1 and 10.8. I think these are too close to determine which one's better or not with my test rig. Underlayment goes underneath the roof, house wrap goes on your walls. So we definitely see a difference between doing nothing and adding those. Pretty substantial. That's 2 degrees difference there. But then we have a bigger jump going to a real insulation, and that's our fiberglass. Now, of course, that costs us, well, quite a bit more, almost 8 times the cost, right? Between 6 and 8 times the cost. I don't know. That looks pretty decent. If you got a shed or something, maybe a house rep will do what you need to do. But we see about 4.9 degrees temperature increase from ambient using a fiberglass. Double reflective did a little bit better, about 1.5 degrees less. I think that's a big enough difference in here to say that double reflective is definitely better than fiberglass, and it's a little cheaper. So then we have another drop down to the spray foam that I used So that's about a 1 degree drop. So our resolution is getting, I don't think I have the resolution per se to really tell a difference. I think there's a difference in there just because it's a big enough jump between it. And we'll go over sources of error after this, and I'll tell you why I think that. But going from 40 cents to $2, you would think there would be quite a bit bigger jump than that. Kind of like what we see over here with the house wraps to the foam. For that cost, we should be seeing something a lot more significant than what we get right here, right? So then we also have the Radiant Guard, Radiant Barrier. It did a little better than the spray foam, but again, I don't know if my resolution is good enough to say definitively it is better, but I can tell you at 17 cents a foot, even if it's a hair not quite as good, it's still within that range of what foam does and what double reflective does, and it's certainly better than fiberglass in this test anyway. That's what I'm going to be using right there. Okay, let's go over some of our sources of error. If I get close enough, I got one light over here, so turn that off. Maybe we'll look a little better there. Okay, so let's go over some of the sources of error. The box. Let's go over the box first. So we see that the box isn't, it's made of 2x4s where we have our test chamber and the heat's flowing through, so it can flow heat out. With a 10-minute test like what we did, that's going to be a bit minimum because it's going to have to heat up the 2x4s and flow out. And the other thing is the 2x4s are on the outside. I'm measuring in the middle, so there's a good, a good 4 or 5, maybe 6 inches from where I'm testing at right there. So I think that mitigates that idea there. And I'm testing everything the same way with the same heat input, so that same systematic error is going to be in all of those. So for a comparative test, I don't think that's going to be an issue. The same with once I turn the heat lamp off, that top plate's hot and it wants to start ejecting the heat back up into the room that direction. All of those have the same input energy, so it's not going to matter on that. What I think the big thing is for error is the way I'm testing the temperature. So it has to go, we got our plate with input energy, it goes through the insulation, then we have the bottom plate, and I'm testing in the middle there, which is not a bad spot. If I had more probes to test, maybe 10 spots, that would be nice. And then also look at the temp rise like every minute or every 30 seconds or something like that, or even more resolution. Check that out. That would be interesting to see. But I think my test equipment, given this, like the cheap one I got off Amazon, I think that's probably my number one error there. Because if I look over at my graph over on the other screen here, and I'll pop that up here. So if we look at the Radiant Guard, I'm saying it right finally, versus spray foam, there's not a whole lot of difference between that and the double reflective. Now we do have a pretty good gap between the Radiant Guard and double reflective. Those kind of seem like they're grouped up into one little group right there. I don't know if I have the resolution to really tell which one's better. I do have the resolution to tell you which one is cheaper per square foot and which one I'm going to be using. Now, I did test the Radiant Guard twice once I saw that result, because me personally, I thought the double reflective insulation was just going to hands down win, or at least be equal to foam. I was wrong on that. But more resolution may change that, and the type of spray foam I used, the way I did it, might not have gave it the best chance, but it's the best that I know how to do with that right there. So I think that some of our error sources right there, just a better temperature tester would probably change results or give me better resolution on this. Okay, blinds closed this time. Maybe we'll won't have so much glare on here. Anyways, coffee, yucky, rainy, 42-degree day today. Okay, so let's go over how I tested the reflective insulations and why I think I might have got the result that I did on those versus the fiberglass and foam. I mean, we know the house wraps, those are just thrown in there. It's better than nothing for sure. What I think is happening is with the reflective insulation, we got to go into a little bit of heat transfer here. So there's three ways that you can transfer insulation or transfer by truck, by car, okay. So you have your radiant, which is, if I get centered on the camera there, I need to move my screen over, that way I'm not, so whenever I see me, I'm looking at the camera there, that's better. So you have reflective, which is just your light energy, radiation, basically radiation, coming out. You have conductive and you have convective, right? So it's a sealed box. So we get rid of convective right there. So the other thing is, given we had the plate and then the reflective, we got rid of reflective as far as energy coming in, it just reflecting it back out, right? We got rid of that. However, on the other side, since it's double reflective, you have a thing called emissivity. So when you get into radiation heat transfer, you have, what happens is it can come in and be reflected and bounced out. You have some that comes in and heats up whatever the material is. So once that material heats up, emissivity is how much it wants to give off heat as radiation. Reflective insulation has a low emissivity. So even though that got hot, the other insulations, once they get hot, they're going to start ejecting out, if they can, by radiant and by conductive. So we pretty much have eliminated radiation right there. It might receive energy coming in through conduction because we're touching, right? So it heats up and then it doesn't want to eject it as radiation, right? So the only thing it doesn't have convection, it has to conduct. So that's why I think those did better, because yeah, they received more energy than what they should have if we had an air gap. They didn't emit the energy. So this test was more the first test of using it as a house wrap, so on and so on. I would like to go further into, well, I'm going to test more things, depends on how good this video does. I'm going to test it with, so we got our box and we put the reflective up here. I want to test it with the reflective on the bottom and see what we get right there. Now, a good test would probably be the reflective with an air gap on both sides. That way you're taking advantage, so like a 1 inch, which isn't as easy as what it sounds when you go to actually do that. I can show you what I'm going to do in my shop, and I'm going to be using the Radiant Guard. I've been calling it the wrong thing for I don't know how long, and I went and looked at the box and saw the who it's from. Was like, uh-oh, that's a lot of like blooper editing. I gotta cross out my mouth or something in here. So anyways, that's why I think those did what they did. We're still testing a quality of the reflective insulation, even though we didn't have an air gap on the top side. We had an air gap on the bottom side. Yeah, it's not 42, it's 50, but whatever. All right. So garage, you can see when I had it built, I had the double reflective insulation, which is the one that I double reflective, because we're talking about two. So what I've done, before I even done this testing, I did a stud wall in here. I think we can probably see over here a little better through the house wrap. So I did a stud wall, right? Put that up, and I didn't put one right here because I have all my electrical, and just did, the 10-footer and a 10-footer and put my studs in there. And on the back of that, we actually have the Radiant Guard. I'm still going to try to call that the wrong brand name. Going to have that back behind there on this wall and this wall. And you see how I'm kind of paneling it with some trim wood. This is like custom wood that my dad made for paneling with his band sawmill. This one has that on there, and I did the bubble wrap over on this wall over here. At that time, I didn't know which one was better. So what I was doing, I was just putting it on the back of the stud wall and then just raising the wall and putting it up there. But I think what I'm going to do now that I have this wall cleared out on this rainy day, I'm just going to staple it to this board, because that gives us our 1 3/4 inch. And then as we see when we come up here, the board, when I do my stud wall, right, actually we'll be like that. I'm going to have another, you know, like 2-inch gap or so on that side of it too, and then I'm not going to have anything in the stud wall, and it's just going to come out. And I don't think I'm going to do house wrap. I think I'm just going to put this right over it and see how that looks. I might get a little bit of reflective twinkling in between the gaps, so to be determined what I'll do there. But that's how I'm going to install that, and that'll give me an air gap on both sides. So this would be like your purlings. That'd be the same thing you see up on the roof. I can get the same effect there, and if I wanted to put my paneling up, I could come through on my rafters. I think that's the right term for those. I could come underneath those, and then I'd have a big air gap in there on both sides. So that's how I'm going to install this. I don't know how that would work on your house, doing it like that, but you can definitely get one of them and do it, you know, the same way. And if you did metal siding, yeah, it'd be easier. But if you're doing like a wood siding, you wouldn't have your purlings on there. You just have your stud wall. So that'd make it a little bit harder to do, but you could always put another one on the inside and then do your sheetrock or whatever you're putting up, right? So that's how I'm going to use the knowledge that I have and install that on my garage, right?